Hello, and welcome to the Biochar Show, where the spark of innovation meets the promise of sustainability. I'm your host, Meghan K, and today I'm thrilled to introduce two exceptional guests who bring decades of expertise and an unwavering passion for biochar innovation, Pat Sherren and Mike Zock. Pat is a graduate of West Virginia University with a degree in forest resource management. With an impressive 30 career as a procurement forester, Pat built enduring relationships with industry leaders, including the Metzler family, sourcing roundwood and chips for them for over 2 decades. After the paper mill's closure in 2019, Pat joined the Metzler team to help launch Metzler Biochar, a company that's reshaping industries with its groundbreaking biochar products, pure char, earth char, and grow char. These products serve as a wide range of applications, from agriculture and livestock production to stormwater management and building materials, all while enhancing carbon capture and environmental sustainability. Mike Zock, another visionary innovator, began working with Metzler Forest Products to develop Char 21, a high-performance blend of large particle biochar enhanced with specialized ingredients. In 2010, Mike founded MKB Company, which became one of the largest erosion control product manufacturers in the United States. Since 2017, he has dedicated his expertise to consulting and inventing cutting-edge solutions in the stormwater sector, including filtration media designed to combat waterborne pollutants like hydrocarbons, VOCs, and heavy metals. Today, Char 21 products are making a powerful impact, proving that innovation and sustainability can go hand in hand. Pat, Mike, and the Metzler team are also deeply committed to community education, spreading awareness about the incredible benefits of biochar and its potential to drive sustainable progress. Their dedication to excellence shines through every product and initiative, underscoring their reputation for getting it right the first time. Pat, Mike, welcome to the Biochar Show. I'm excited to dive into your inspiring journeys, explore the innovations of Metzler Biochar, and learn more about your vision for the future of this transformative industry. How are you both doing?
Excellent. Good, Megan, and congratulations on your new awesome Biochar show.
Thank you. Yes. Launching, so it's coming together. We get lots of exciting people like both of you. So why don't we dive in? I'm curious as to what first drew you into the whole biochar industry, and I guess what excites you most about its potential. Pat, do you want to start?
Yeah, so it wasn't really my choice per se to into the biochar industry. My 32-year career as a procurement forester came to an end, and Alan Metzler, who I had done business with for 20 years, said, "Hey, Pat, we're thinking about crazy things, and we don't have time. And would you consider, thinking about them for us?" And I said, "Sure." He said, "Well, the first one's biochar." I'm like, okay, well, I've now heard the word. We're off to a good start, right? But like most things, you kind of dive in and see cool things and talk to interesting people, and you think about what might be possible to, transform the world. If you look up biochar on the Google machine, like in the first 10 or 20 minutes, you think it's going to save the world. In 40 minutes, it's probably going to be part of the answer, but not the only thing, right? So, I love crazy idea and doing new and innovative things.
Mike, what about you?
So my motivations have nothing to do with what Pat just said. Absolutely nothing. So I've been working in erosion and sediment control for about 15, 20 years, and we're always studying materials we can put in a 3-dimensional flow matrix, whether a filter device, a filter chamber, some sort of material that we can flow polluted water through and get the pollution out. Could be sediment, could be hydrocarbons, heavy metals. So that's my motivation to study these materials. Metzler making this large chunk biochar makes a very nice 3-dimensional flow matrix. I can flow water through it nicely. Okay. So that was my initial interest. One of the things that I think is a little bit off in the biochar world is the origins seem to be in the organic world or in the forestry or in the sort of, this new, whiz bang, organics type thing. That is not at all what we look at. Metzler produces a super high quality, high carbon, basically almost pure carbon, three-dimensional carbon chip that is highly porous. That's a building block. That's not the end game. That's a building block. And the process that they use appears to come from forestry or organics or recycling. But the product itself is a highly functional device, a thing for the next step, whatever it may be, whether it's growing vegetables more effectively, sequestering pollution effectively, or whatever you're doing is your next step. This process of creating biochar through pyrolysis that Metzler's undertakes, as do other factories, creates an incredible building block for whatever you're doing next. That's its value, not its origins in the organics or in the amazing science world. It's a really, really functional piece of carbon.
Well, and I'll throw in there, Mike. So, the Intergovernmental Panel on Climate Change talks about biochar being one of the most effective, shovel-ready, scalable ways to sequester carbon, which is all great. I'm cool with that. But there's a product there that makes a difference for people, that's usable. And so I think that's a great thing also.
So building on what Pat just said, if the source material is a secondary reuse or recycling type effort, right? We're doing effective reuse of a material, that's valuable. If during the pyrolysis process, we can effectively use the heat, right? Like Metzler does, that's very valuable. If we can sequester carbon a little bit, we're not going to make a big dent here, but we can sequester carbon. That's pretty valuable. But at the end of those three good things is where the real story starts with biochar. And that is the functionalness. Now, what can we do with the high quality carbon piece of carbon that is full of tiny little pinholes, okay, as the next building block on what you want to accomplish? That's what's amazing. Those first three things, pretty valuable. It's a good story. None of them are a home run. The fourth one is the home run.
And Pat, how did your experience in forestry, and you said you did forestry and procurement, shape your perspective on sustainability and biochar's role in resource management?
Well, there's this saying in the wood business, and it was a bumper sticker: wood is good, right? So the forest is a solution for many of our problems. A healthy forest, right? A properly managed forest is a solution for many of our problems. So I think understanding the benefit of wood fiber and all the things you can do with wood helps. I think working at the paper mill, you had to beat your head against the wall to get stuff done, and that makes you a better person. So I learned to beat my head against the wall until I broke through. So I think that was a couple things at the paper mill that set me up here.
And then, Mike, you were talking about Char 21. So what's the story behind the creation? And I guess, why is it a standout product in this whole stormwater space?
So again, it's great that we can use a recyclable material or a beneficial reuse of something, in this case, wood chips from land clearing. It's great that Metzler uses the heat effectively, and they do. It's really smart how they use the heat created by the pyrolysis effort. And then we're sequestering carbon. But now comes that great piece of carbon, and we're mixing that in with switchgrass and reactivated carbon to create a three-dimensional flow matrix for pollution that grabs, you name it, hydrocarbons, heavy metals, PFAS, volatile organic compounds. Basically, nastiness in the water is taken out, running it through this flow matrix. So Char 21 was our effort to take that carbon chunk, right, that really valuable little carbon sponge, and surround it with more of a broad spectrum with switchgrass, which has its own benefits. activated carbon, in this case, reactivated carbon, that has its own benefits, to create a broad spectrum pollution grabbing flow matrix. We can run water through it. We can run stormwater through it and clean that stormwater. And we can do it on a large scale. We can do it in a particular location. And it really gives us incredible tools. The thing I'm probably most excited about is PFAS, right? Those forever chemicals that we're talking about, and the ability for this media to grab PFAS and take it out of running stormwater, active surface water.
And so we were talking earlier about Metzler Biochar and the products that they're carrying now. So you've got Pure Char, Earth Char, and Grow Char. Can you walk me through the unique features of these applications and innovations, like if it ties into Char 21?
Yeah. So Pure Char is biochar. We have two versions, chip and dust. So the chip comes from sawmill chips or chips that we make. It looks like cornflake size material, and that's what we use in Char 21. And then we've got a dust version, which is sawdust from our firewood processing area. So another co-product right on site. Grow Char is our proprietary biochar compost blend, and Earth Char is a soil blend with Grow Char and some more biochar for good measure, which is great if you need soil for like a raised bed planting or new planting. But I have to say, one of the really, I think that as important for us, we harvested the heat from the oxidizer to displace several thousands of gallons of propane per year for another process. You know, when we started the discussion on a particular day, biochar was the thing and the heat was the gravy, and the next day the heat was the thing and the char was the gravy, and kind of back and forth. But we knew that we needed to make the heat a part of what we do in order to make this totally viable. And it was great. We were able to get back to our roots and use biomass heat instead of propane to heat treat our firewood.
Very cool.
Yeah, Megan, if you ever get a chance to come out and see it, it's pretty impressive. It's a little bit forward-thinking engineering, a little bit of MacGyver, and it's really quite effective, what they're doing. So again, reusing a material or effectively using a byproduct, creating that heat, sequestering carbon, and the outcome, and Pat talked about, there's a dusty material that's a very fine powder. Now, I can't get stormwater through that, but then there's a large chunk, and this is what was very attractive to work with Metzler's, that they produced that large chunk biochar, and it's from chipped wood, from land clearing typically, but that is of a gradation that I can get stormwater through it. So that's where we take it in the Char 21. The other Char 21 is of a much smaller gradation, more of a sugar or a powder. That's going to be good for agricultural applications like soil amendments that Pat's talking about.
Going back to, Mike, with your work in stormwater filtration, so it addresses complex challenges like pollution from VOCs and heavy metals. So how does biochar make a difference in the field? You were saying it almost blocks the water out before it goes down the drainage. Is that what you were?
So a lot of work had been done with compost over the last 20 years or 20, 25 years. Very effective material. Couple of problems. It's kind of a live material. It's heavy. There's different qualities depending on your feedstock, as there is with biochar. But I felt like I wanted to move to the next material, and I wanted it to be shelf stable. So biochar really checked all those boxes, and a little bit of a lighter material to work with, definitely shelf stable, lets me create consumable devices that can go out to a construction site, or more interestingly, let's say an industrial site, such as a rail yard. Near us here in Altoona, Pennsylvania, is a major rail yard. And they've got trains coming and going and boxcars sitting around and industrial equipment. And there's fluids all over the place, right? There's, radiator fluids and lubricants and other things. So we're constantly aware and giving concern to how do we make sure that we grab those sort of pollutants when a rain comes and starts moving those towards a stream or a river, okay? And the major rail yard in Altoona is right next to the Juniata, okay? We need to surround catch basins, the inlets where stormwater goes into, maybe a channel where stormwater goes down through, and we want to place some temporary devices, or let's say consumable devices, where that water can go through that filter media and we can grab the pollutants out of it in active stormwater. That is a relatively new concept, and the biochar lets us make products that can do that.
Is the biochar in just like tubing, or what do you put the biochar in the drainage?
The three first products that are coming to market of Char 21 is a 5-inch diameter by 10-foot long tube, and that could surround a catch basin. There's an 8-inch diameter by 4-foot long that's more of a shorter and bigger unit that could be modularly stacked into a channel, a flow channel, or around a catch basin, or let's say around a dumpster that may be leaking oil or the risk of oil. And then the last one is about a 10-foot, 9-inch diameter that has handles. It's portable, it's movable. So these things can be deployed between rain events, just constantly there. So when rain comes, or in emergency situations, if there were a spill, they could be deployed to make sure that we're grabbing pollutions during a rain event or during the next rain event. So modular consumable products that can be brought onto the site and deployed around a site as needed.
What about when the snow melts? Is that also something that we put down before spring sort of comes to kind of collect that too?
Yeah. Here in Pennsylvania, they use a lot of road salt, and the salinity can affect the bodies of water. We really can't do anything about that with biomass and filtration. But what often happens is you're going to get a sheen off a parking lot. You'll get some radiator fluid. You'll get, if you went to the catch basin, let's say in the corner of the Walmart parking lot, you would be shocked to find the nasty things that go down that catch basin. So we want to be in places like that, close to where the pollution is created, so that we can grab it, and then on a rotational sort of service interval every month or every couple of months, pull that thing out and put in a fresh one, so that we're always got some amount of pollution absorbency of where it's created.
The idea, right, just let's keep it on site. So it's in our case, it's not going to Chesapeake Bay.
Megan, you asked a great question. Anytime we have a stormwater device that's going to collect pollution, we have to be sort of a little careful with where we go with that. If we're collecting things like heavy metals, the biomass is not going to consume those. We probably have to take those to a landfill that's designed to receive that kind of material. Some things that could get into such a device, like nitrates or phosphates, can be consumed by the biomass and the microbes in it. But generally, composting it or taking it to a certified landfill to receive such materials, because they are going to be pretty concentrated with pollutants.
Just want to, while we're talking about Char 21, a big shout out to our friend Sean Gruszecki, Dr. Sean Gruszecki at West Virginia University, and the whole Mass Bio team. They've been great support in developing to Metzler and developing our biochar product. And we were able to use a sub-award grant from a USDA NEFA project that's housed at WVU, and supported by 4 or 5 universities here in the Mid-Atlantic region to fund the development of this. So, government and industry and academia come together and do something that benefits the market.
And that sort of goes on the whole with Metzler Biochar, because you contribute to combating, climate change and carbon sequestration. So that also continues what we were just discussing.
So Megan, I'd like to add to what Pat just said. Sometimes you need a little bit of courage, a little bit of leap of faith. Okay. And I still remember the day when we called up Dr. Gruszecki and we said, hey, so got this crazy idea and we're going to need a bunch of money to test it. He's like, oh, okay. All right. Just, just tell me what we're going to do. And so Pat's right. The team at West Virginia was very gracious and supportive of us doing some amazing testing last winter. We simulated 20 rain events over 3 months. Now, that's a pretty substantial test. Okay. And thank you again to Pat and the team at Metzler's for hosting us. We constantly were stealing the water hose to fill up our water buckets and put in pollutions like arsenic, chromium, cadmium, nickel. Okay. So we were testing heavy metals and other pollutions, and we did that all at Metzler's. And we produced a report on that. And that forms the basis of really the Char 21 product family. And those products are moving into the market today, cleaning stormwater across the country. So thanks again to the team at West Virginia.
And, right, the market plug, you can find Char 21 stormwater products at Hale and Hardy, Halen without the van, and Hardy, like Lauren Hardy.com.
Very, very interesting, focused, sort of environmental, industrial pollutant manufacturing company. They're a little different than other people in this space. They're brothers, Troy and Josh Beaver. They've been doing this for about a dozen years. They've created a tremendous following and have very unique products. So it was really a great fit to work with them to bring Char 21 to market, and it's going very well. It's going excellent.
Congratulations. That's fantastic. So what do you think are the most promising industries or sectors that, besides you were talking about rainwater, stormwater, that really can benefit from biochar technology, but really maybe haven't fully embraced it?
Every industry sector. So let's talk about this, right? Agriculture. So biochar as a soil amendment significantly increases water holding capacity, nutrient transfer, soil aggregation, water infiltration. Animal production is a great addition to bedding. Put it in the poultry house, absorbs ammonia and water. By holding that ammonia, you are holding nitrogen. And then, chickens do what chickens do, and they eat it. And so it acts as a toxin binder. We did a little study with some more mass bio money with Tennessee Tech, and didn't show some of the things that we expected because the parameters of the trial, it was like a brand new chicken house and there was no pressure on it because it was a small number of birds. But two things we did see, right? Improved conversion. So the chickens did use the feed more efficiently. And when they posted the birds, the internals of the biochar birds, it looked healthier and just looked better compared to the non-biochar birds. We have biochar in innovative ceiling tile. We have biochar in innovative outdoor cooking product. We have biochar in concrete research at Penn State.
Asphalt. Asphalt is another one.
Verde, Jack Wong and Verde Resources, I think, is successfully adding biochar to asphalt. And I believe they've got some Department of Transportation approval. It makes the asphalt more water resistant. They can apply it with water instead of a solvent. It's UV resistant. So there's just all kind of crazy things going on with biochar.
I'd like to take a stab at this answer. Okay. So I think a material like this, a pure carbon chunk, and what the people, and I don't remember their name, the Fortress is behind. They use the term biocarbon. I think it's a very appropriate term. We're saying biochar, it's pure carbon chunk. It's a pure carbon. We're creating pure carbon. So then the question is, what are the industries that we can make meaningful momentum, right? Meaningful, impactful momentum. Clearly, agriculture is one of them. There should be momentum in moving biochar outputs into agricultural fields. They know this, okay? They know this. The second one is where I'm working, I think, is stormwater, okay? We know it takes pollution out of stormwater. So there's growth and meaningful impact there. The third one for me, though, is actually steel production. And that's where the company that is behind, Fortress is behind, and I can't remember their names, but they are attempting to replace the carbon you get out of the ground with coal and coke creation with biochar. as sort of the source material. So instead of having these big mining operations and all the nastiness that comes with creating that coke, they can make it from biochar. And I think it's a lot friendlier. I think it scales a lot better and actually helps solidify the stability of steel production in the United States. Now, we pull that one off. That's not a $1 million thing. That's $1 billion thing.
That's biochar by the train load, not by the truckload.
That's right. So, Megan, I want to give you another example of this kind of impact that's possible. Okay. 10 years ago, in 2015, how much natural gas did the United States export?
You got me on there. I don't know.
Nothing. Zero. In fact, 2007, I think, was the largest year of our importing of energy. So in 2015, we didn't export any natural gas. Russia, Australia, I think Qatar, and a few other places. Okay, here we are 10 years later. And there was a momentum, a dynamic, massive push for oil and gas exploration, not only in Texas, but also in the eastern United States, Pennsylvania, West Virginia, Ohio, in the Marcellus and Utica fields, because the technology of fracking came along. Now, it's controversial, but to be honest with you, it's pretty much done. It's happened. Last year, we exported about 14, I think, trillion, maybe billion cubic feet of gas. Probably as much or more than any of the other guys combined. We went from 10 years ago, nothing, to the world's largest dominant natural gas exporter by far. No one's even within half of what we're doing. That's what focused momentum can do when technology is at play. I tell you that there's potential like this in biochar, in agriculture, in environmental remediation, in a cleaner environment, and then finally in domestic steel production. Those are possible. It'll be very interesting to see 10 years from now where the steel production, how far they've got with the biochar.
Well, and I'm going to add to that. Tom Nelson, who is an innovator in the biochar space, and Plants and Goodwin, they seal oil wells, gas and oil wells. And they're doing some really good work on how do we use biochar, one, to place carbon, but two, seal the wells off more effectively in a structural way, because we believe the concrete will be more flexible and won't crack, but then to capture gases like methane that we don't want released into the air. So, and then another, when you think about the future, right? So activated carbon is made from coal or imported coconut shells. And
from Asia.
Right. There is some real work going on how do you biochar has already got a lot of surface area. How do you transform it into something with much higher surface area that could replace activated carbon that's either being imported or the feedstock's being imported? So how do we keep it all in the U.S.?
Yeah, and Pat brings up a really good point. That is a major fundamental shift in sort of the status quo. A lot of the activated carbon in the United States comes out of Asia. And it comes to the West Coast and then gets shipped all the way across the country. Okay? Imagine if we can make high-quality activated carbon right here in central Pennsylvania. By the way, another thing to add to what Pat said that most people may not know is old wells, old gas wells, natural gas wells in Pennsylvania that weren't sort of decommissioned correctly, release a lot of methane. It's a big item on the Pennsylvania DEP, Department of Environmental Protection, list of things to correct. They put a lot of effort into it. They've got a team of people that are working on capping wells and trying to reduce that methane. And some of the stuff Pat talked about is being looked at for that. But it's a big deal here in the natural gas area to cap, to be responsible, get those old wells capped. Technology and innovation in solving the world's problems with pollution, global warming, rising sea levels, and so forth.
Feeding people.
And feeding people is a good example. So, Megan, it's very simple. We're not going to regulate our way out of the challenges that are in the world today. We're going to innovate our way out of it. So things like biochar need to be supported. New initiatives with creative people that are willing to take a risk, willing to reach high and say, what if we could do this? What if we can create 1 million tons of biochar that's deployed in our agricultural fields such that we more efficiently use phosphorus, okay, and use less nasty chemical pollutants in our food sources? What if we can create technology to make the water cleaner, the air cleaner? What if we can reduce bringing coal out of the ground in very unfriendly and nasty ways, and we can create the products that coal was used for, such as steel production? What if we can make concrete that's the most widely made material on the planet friendlier and less polluting and less nasty to make? We need to innovate our way out of some of the challenges, not regulate. And this is where the role of government plays in, to support innovators like Pat, like the people at Metzler's, creating new products, testing the possibilities of the use of these materials. That's why what you're doing here, Meghan, is so important. You're at least creating a forum to get innovators on the channel and say, hey, what are you guys doing? What do you see? What's possible? Did anybody think 10 years ago, when we didn't export any natural gas, that it could be possible today that we're the world's largest natural gas exporter by far in 10 short years? That amazing change has occurred. So innovation is the key. I'm an innovator. I'm so grateful to Pat for letting me go into their offices and into their warehouses and use their space and help me talk Sean Grishecki in and giving us money. But amazing happened. Today, important, valuable biochar products in Char 21 consumables are moving into the market, and we're cleaning stormwater every day. And we're just at the beginning. Better is possible, more is possible.
I think it's important too, like just in the sense of that's sort of why this whole thing started with learning. I think as we sort of get older and we sort of look at history too, like we were talking earlier about obesity, and I was saying, it's interesting that like our grandparents, no one was overweight back then. The food was different. Like you were saying, what goes in the earth now in agriculture, it's very fascinating. And I do think there has to be something to go back to that. Like we can't reverse history, but just to make it better going forward for, kids, grandkids, etc. And I think it's really important to get the word out so people understand what biochar is, what benefit it has, and how, like you said, we can get the train load of this and not just a truckload.
Well, and so biochar, let's say in Europe, Asia, and Australia, is more of a ubiquitous product. They're just using it, feeding it to the animals and all that stuff. And in the U.S., right? So you've got the bell curve. It's the crazies and the true believers, and then the one, and you start to get the curve, and then you got this gap, and then you're normalized. And everyone's like, oh, this is the best thing since sliced bread. Why weren't we using it all along? Well, those people were telling you for 20 years you should be using it. But I think we're getting ready to jump the gap in the U.S. And again, I think Mike rightfully said, thanks for the megaphone here about what we're doing with biochar and what might be possible. I think if we unleash innovation in the United States, and I'm not speaking against anyone else, any other country, I'm just saying if we unleash it in the United States and Canada, on Canada, right, and we don't get in the way of that by trying to regulate everything to the last degree because we're afraid of what might happen, great things will happen.
Meghan, I want to give you a couple examples. About 10 years ago, I was asked to give a talk for a big organization, about 400 people. I'm like, okay, well, you're going to give me like 2 hours. What do you want me to talk about? He goes, you make it up, but whatever you want. Okay. So I said, is all this work that we do in paying attention to the problems, low E-glass, low VOC paints, Energy Star appliances, higher mile per gallon cars, right? On and on. There's things that we're doing. We're creating behaviors to try to make things better. Is any of this making a difference? Any of this? And I went and researched, and I found amazing things that, heck yeah, were making a difference. Okay, let me give you 2 examples. At the turn of the 20th century, 1900, compared to today, we have grown in the United States dramatically in our population. Yet, we have more forest today in the United States than we did in 1900. Because from 1800 to 1900, we did so bad. And thank God we got Canada to get all our wood from now, right? So I'm just kidding about that. We are managing more forest now. We've created more forests.
And I have to interject, Mike.
Yes.
I was on a tour and I said something like that there's 75% of the forest land that was here when Christopher Columbus showed up. This is the forest management plug, right? And this guy was like disgusted. Only 75%. I'm like, are you kidding me? Think about all the developments and the Walmarts and the highways and,
the hundreds of millions of people.
I could look to the mountain behind us and say, in 1900, that mountain was bare. And it is now green because of forest management. Okay.
Here's the second one I want to leave you with. In 1965, there were a lot less people, probably 200 million people in the United States. Today, 330 to 340 million people in the United States. Would it surprise us to know that we use the same amount of water today with 340 million people than we did in 1965 with 200 million people? Why? Because we care. We're taking actions. We're conserving, right? So paying a little attention, giving innovation and technology a good chance to make a difference. This is how we're going to continue to do better in the world. So when you ask, where is Biochar's place? I'm suggesting to you, as Pat said, we're just past the early people saying there's something here, to people are starting to go, I think I could make $1 million difference over here. And then someone's going to say, I'm going to make a $10 million difference over there. And then all of a sudden, someone's going to say, I'm going to create heat that we didn't have at any price. And suddenly, we're going to be producing steel in a whole new way, and so forth. We're just in the beginning of biochar. And I wish we'd stop calling it biochar because it gives certain things in our minds. It is a highly pure form of carbon that is usable in the next process, that is smartly created, responsibly created, and can allow amazing in agriculture, concrete production, asphalt, steel production, the cleaning of water. Okay? It's an amazing stepping stone to the next amazing.
And this is why you're on the show.
And this is why I love technology and innovation. I've always been a technologist. I've always been driven by the possibility of innovation. And, I have a background in computer science. I'm a techie guy. I don't even know how I got here, but I think, in working with people like Pat, we're trying to make a difference every day. And Char 21 is a big step forward. And again, Pat, thanks for having the faith in us to sort of think about it and bring it to market together.
Well, listen, I used to say I had 12 to 24 ideas a day, and they were not all for me. And that's an interesting idea. But I get to chase down crazy ideas and support crazy ideas and be part of things that are just, very interesting and weren't there before. So, yeah.
On closing and ending this, what's a takeaway for the people listening that you would give them on biochar? Or like you said, we're not calling it biochar, but just on what you're hoping to accomplish with what you're working on.
Yeah. So we want to be useful. Alan always said we're a service organization, right? And I would say to him, I need this, and this done at the paper mill. And he'd say, yep, I can do all of it. And just don't worry, Pat, I'll take care of it, right? And it was awesome. And we at Metzler want to be useful. How do we make people's lives better with forest products that are sustainable, right? If you harvest trees, hardwoods, you have to kill them to keep them from growing back, right? So the forest is sustainable beyond belief. And how do we use that forest to our benefit? How do we conserve it, not preserve it? How do we use the solution to people's problems to increase healthy forest and good forest management, which benefits us all?
Fantastic. Mike, what do you think?
So my answer to what you asked is a philosophy. We're not going to cost reduce our way out of our challenges. We're not going to regulate our way out of our challenges. And we have to inspire young people to be inquisitive and optimistic and challenge the status quo. And the answer to that challenging is technology, innovation, science, okay? Investigation of new possibilities. Ask ourselves, what if? This is how we got to the moon. This is how we'll get to Mars. This is how we'll clean the water, clean the air better, feed more people. It's going to be through technology and innovation. What's exciting about biochar and this pure carbon material is, as Pat said, we're sort of past the early excited people, okay? And momentum is starting to form for industrial application, okay? Big things are happening with the potential of biochar. That's a very exciting moment. It's a long time in coming. And that's why it's worth starting to have shows like this. In general, I am a big fan of innovation and technology, keep moving forward. And specifically with biochar, we're sort of over the hump, and I think we're going to do some open field running. It'll be extremely interesting to come back in 10 years and look at how much has been done. And the big one in my mind is three, agricultural stormwater, and then, of course, steel production, which is a big deal in the United States in today's world climate.
Fantastic. Gentlemen, thank you so much for taking the time out of your day, coming on here and giving us a lesson in Metzler, in biochar, in Char 21, in just innovation and sustainability and going forward, making our planet hopefully a better place to live.